Hey everyone, this is Yuchin. We're here together with Mike and Matt, and today we're gonna review Sputnik DAO contract, second version. It's still in works, and a lot of stuff might change, but it may give an idea what's new with Sputnik DAO or Sputnik DAO. How, Mike? How you say it on English?
I say Sputnik.
Sputnik.
It's Sputnik.
Yeah, exactly, Matt. We said Sputnik. Well, anyway, let me present my IDE. It's still loading, still expanding macro. But for now, let's first start with the toml file. So this is 3.1. Then a lib. So it has some interesting stuff, such as blockchain interface. And this is low-level env API that allows you to call runtime methods directly. And this is how env method actually calls anything. So we can take a look later. This is needed for efficient upgrades and efficient blob storage. And we will take a look how it's done. So it uses the new API of storage keys, which is enumeration of a bunch of storage keys for maps and objects. Then it also designed for upgradability, which is an interesting way of doing it. For example, contract data is kind of main contract object, but it's not basically it's not the main object that is stacked with near bungee, so it's not directly deserialized. Then we have a version contract data, which is enum that has a current contract data, and the contract itself right now implements a fungible token interface plus that version contract data. So now it makes it problematic. So every time you're trying to access the data, you pretty much have to, instead of directly accessing using self, you have to call something like self.data. Like into like get data, and you will see how it's done.
So from a high level point of view, this is a good way for folks to like model their smart contracts after where you're starting from the basis that you know it's going to be upgraded soon. So this is like how you set it up for upgrades later, right?
Yeah, so this is like one way of doing it, but it makes it like more complicated because you have to wrap all data access through self dot like mutable data or view data, which is internally like unwraps it from this enum. So makes it a bit more inconvenient. While you don't really need to have a version contract itself, because you can always read the previous version during the migration and convert it to a new version using some kind of into method. And then you drop the old version from the code at the next version upgrade. So, but internal objects such as, for example, everything that is within the collection, persistent collection, ideally should be versioned. So for example, a proposal here ideally should be versioned, because if you have like thousands of them in the collection, then you cannot really upgrade them easily at once. You have to like either send multiple transactions that will upgrade all of them, or have an ability to use both the old version and the new version, but you cannot mix them in a single map. And other options, like you reintroduce a new map, like proposals v2, and then you have backward lookups. So you look up proposal v2 first. If there is no proposal, then you have to go look up at the proposal v1. So instead, a versioned object for a map makes sense. But yeah, for contracts, because you don't really have more than one instance of a contract, then it probably doesn't make sense, because you can always upgrade that single instance in a go. Obviously, like some information like this fungible token that kind of non-upgradable right now. So your data should go after this, so like data that you plan to modify, because this one should somewhat keep the same. Anyway. Okay, so what else is interesting here? So we have a lazy options. The idea here is this policy and config can be pretty large, but not needed for every method that we call. So we don't need to deserialize it every time we deserialize the entire contract. So it's more on demand than initialization. Since this is a new API, it doesn't need to check for the existing state. So it initializes data by passing config and policy, which just calls the method upgrade. So let's take a look. What is this upgrade doing? So the policy has two versions, default and a current. Default takes a list of accounts. It's I guess Sputnik v1 policy, which are board members of the DAO. And v2 is the policy that is a custom one. So it just casts it to the current policy always. Okay. So a bunch of lookup maps and blobs.
I have a quick question about the policy, if you don't mind. Is there a reason that it's like an optional lazy value? Like if there's always a value set for it, is there a reason why it isn't just like a lazily loaded item from storage?
Well, it's kind of like a goal for lazy option is, I guess it would be just a lazy access. So it doesn't need to be an option. For example, like for policy, it makes sense to always have a policy, and for config, it always makes a reason to have a config. At the same time, it doesn't prevent us from not having this object in a state. So it makes sense to design it as an option too. But do you see any like improvements that can be done if it was just a lazy object instead of like a lazy option object?
Well, you just might be able to have some like guarantees that that state does always exist, like on instantiation, that it would always have to be, stored in storage, so that you didn't have to do like checks every time you used it to make sure that it is like that it exists in storage. I don't know, like there could be some like just a purely benefit to UX, not necessarily like a functional benefit.
Right. Yeah, it makes sense. But I mean, I think here, anytime you access it, you unwrap it, and that's how you kind of make it. So in this case, you would just move this expectation out of this collection. Okay, and then finally, we store the size of contract before the state is initialized, plus any access key that is on this contract. Not sure why we need this, but okay. Then we initialize the current account as the owner of the token. But we don't really give a full supply to the token. So I guess this may be done separately, but we just register that this account exists on itself. Okay. Yeah, and then returning the new object. So this is a migration. This is no op implementation. It verifies that it called by itself. And then it reads the state using the, again, self, or old self in this case, and then migrates it. Well, obviously this is going to be called during the migration. So you deploy a new code, then you read the old state, then you do some operation on the state, for example, initialize some new collection or modify some value, and then you return the new object.
Got it. So between 123, 124, you set up the new stuff.
Yeah, and this should be something like old contract, and then it should return itself from this. Something like this. You want to like convert it from the contract. Okay, remove blob. So for this, I need to explain what is blob and how to add blob. But idea for the blobs are you can store efficiently a large size byte object under an account. So a given account can store some data, and I guess pay for this using storage. Okay, but it's a removal, so we get the crypto hash from this. We remove this crypto hash from the collection of blobs using data mute. So data mute is actually returns a mutable from mutable self, and it returns the object. So we verify that the object you returned is the who called this, and this is kind of common pattern for near SDK or like our environment, where you first take an action on the assumption you have access, and then you can verify access after you took this action. And that way, if this fails, then this action gonna be rolled back, and like entire state gonna be rolled back. You just burn some gas. Also interesting that blobs are storing hash to the owner. So it's not really like the actual blob data, but instead it's just a record who owns this blob. And then we store this blob separately in a storage remove using a kind of hash as a key. So that's not super secure, assuming that there may be some weird collision if you have a lookup map that may have a key. So for example, this lookup map. So if your hash starts with is like enum index this, and then you have a length of the account, and then you have the account itself that is gonna be equal up to 32 characters total. So account should be like 27. Then it may have a conflict with the blob data that we store here. So maybe we should instead modify this key, like using storage access as well. So something that would be more secure if we would do storage keys hash. Then obviously it has something to Vec. I don't remember API, even so I implemented it. Okay. Yeah, into storage key. So you do storage key hash into storage key, and that way you avoid collisions for sure. And it's almost as efficient. You just do like 1 extra byte in front. Maybe it's like more like a blob. What did you import?
In Austin, a lot of times it's a little bit uncommon to have like env storage remove. A lot of times people will just be storing their state using the data structures and all of that, but this is a way you can do it, a little bit more low level way of talking to storage, changing storage.
Yeah, absolutely.
Yeah. Okay. Well, I also don't have Rust FMT enable this yet. Then we read the register len using env. So it's a low-level API that we know that storage remove is basically uses evicted register, which is apparently not public. We can read evicted into memory, but we cannot really read the length of the evicted object through the env because it doesn't expose it. So there we read the length of the evicted. We unwrap that this is an option and that we get the length of the blob. Next we do storage cost, which is plus 32, which are the size of the hash. What we are missing is probably plus 40 and plus 1. So you need 32 for the hash. Now I added 1 for the blob, and 40 is like a standard config that probably should be exposed as well. That is a single key in a runtime takes extra 40 bytes for storage usage of the account. But nothing to worry about. This separation will probably like burn more gas that you'll get more refund from this 1 extra character that you lost.
So I have a
Not
question.
necessary 40 for the key.
for the env call to get the storage evicted, which retrieves the value that was deleted on the env storage removed before, does that cost extra gas? Is that the reason you use the register length instead of getting the actual bytes?
Yeah.
Gotcha.
Yeah, because otherwise you would have to actually read it. While here you don't really need to read it. You just like query the size, which should be much cheaper. At the same time, I don't understand why not like write it. Oh, storage before, and then you use env storage usage. Then you do storage after. You don't need to like this register at all. So storage used or released. And then you do storage before minus storage usage. And then you don't need to read the blob lengths. You don't need to compute any of this. So you can just say, well, storage cost is storage released. And that's it. So this is like, seems should work because this operation is actually gonna do the removal. Okay, so here's a WASM code. I need probably to enable a target, but I will not do this. It's for some reason it doesn't let me. To change the target.
Oh wow, what the heck is going on here? This is like
So this
brand
is
new.
pretty much standard stuff that happens behind the scene by nearby engine macro. So we set up a panic hook, then we set up the block interface. The reason why we have an interface is so we can run unit tests, not on a real environment, but on a simulated environment. If it's a simulation test, I feel like this can be avoided completely, and we can just directly use the native interface WASM32 target and not needed to set this blockchain interface to use for env. Then we read the state. So this is how we deserialize the contract. And it assumes this is a Borsch. Then we get the mutable data and this unsafe block of block interface that does a bunch of operations on env that are not exposed. In theory, because it's a WASM32 target, you call in the system methods. So in some way, you can just natively like grab this and call that instead of doing b borrow as ref and stuff like this, because you just put this in as a block interface. But anyway, I guess you need it for state read. So input 0, it actually reads entire arguments vector into register 0. Then we hash it. So this is how we point that we need to hash register 0 and store the value in register 1. Then we verify that there's no key by checking if the hash with this key exists. So this is what I need to modify. Because I actually may want to read the hash out with my operation that I did that added one extra key in front. So something like hash and key. I cannot read key because I need to read register 1. No, I need to register read. How do I do register read? Register read. Okay, that's not that hard. And register read, that will read me a vector. Default. Anyway, so this is, we're gonna read the blob hash from the register of 1. And some res. Well, I guess it doesn't need to be no. Oh, okay. If it doesn't have a links. So what I probably can do even better is just read it directly here. But then register 1 blob hash as PTR. So yeah, we read the register. So I have a block hash now. Now I just need to check that there's no key. And this is we do storage as key. And then we need to use the way we wrap this blob in.
So also, like, I don't want to interrupt this flow. I'm just curious, like, where blobs fit in. We're talking about like a DAO. Maybe I just like missed what.
So blob is needed for upgrades. We pass it as like a code that is 300 kilobytes. And we don't want to touch Borch deserialization or serialization at any moment of this. So it usually like just straight, I'll give this blob to like upgrade some remotely or upgrade us using this blob.
So it's a
hash.
It's a contract. It's a WASM like blob.
Yeah, yes, it can be WASM blob, for example. Okay, so if there is a key, we say no. Wait, why it's a queue? So there is no key. Blob length. We got the register. What is doing storage key? It doesn't mess with registers. Okay. Then we compute storage cost. Again, we can do this later. So we can get the current storage usage and then release storage usage. And here. So storage added is going to be inverse. Now the key is different, so we need to do blob key, and we where I was doing it here. I guess here it was read already, but blob key. Ooh, nice. I just need to not forget what to do. All right, so we basically pass a blob key as a key to write the blob. Then we store register 0 at this place, and it returns us data in register 2. So I guess we don't need to verify that the key didn't exist, because we could have basically just store it there and see that the second is none, but that's fine. Blob lengths, we don't need blob lengths either, which is great because we just rely on the actual storage that we increased. Plus we compute how much your account costs. So we store the blob hash, which is I have as the name of the hash. And then we compute how much storage we added. After these two operations, we compute how much it costs and make sure that you attached at least more than this. Then we say, oh yeah, let's increase the locked amount by this storage cost. Even so, like, why we even computing this? Because it's a natural storage cost. So like, why not just every time we need this locked amount, if it's only used for storage, why not use it for like, just take a current storage usage, multiply it by the cost, and this is how much you locked for storage. Blob hash string. So this is because we use them. We write non-standard method. We have to manually return it, and the way we do this is calling JSON to string of this object, and then we get it into bytes, and then we write it down as a value return. And finally, we store the contract because we modified these blobs. Well, it's a lookup map, so we don't need to. So yeah, this operation is probably, oh, because we did modify lookup amount. Anyway, so this is like low-level interface that is fairly super efficient for writing like 300 kilobytes of a blob into the storage and pass it into the input through, as well as like computing the hash of this natively. And this is probably the most expensive out of all of them. Maybe storage write or storage read are also expensive, but this piece is probably more expensive. Okay, we still have 10 minutes, but we're done with the, I think we're done with this lib rs. So this is a metadata that you implement, and I mean, it all takes it from config, but probably it's worth to just store fungible token metadata itself instead of taking a replicating all of these fields in the config. It's only like the extra line is this purpose.
Could I see that data mute thing? You did like a self data mute or something. That seems like new to me.
So it has just a mute reference on self, and that's why this one has a lifetime of the self. So while this lives, it means you cannot borrow self mutably or immutably until this object is released. And when it's released, it actually modifies data internally. And data is just an immutable borrow.
Yeah,
So
overall, this looks very different than our other contracts that we looked at, huh? I'll have to dig into this more.
Let's actually look into probably some action where it actually uses a blob. There's more to explore, such as like proposal kind and stuff. Proposal kinds is like different types of actions you can do. And one of them is like upgrade self or upgrade remote, and you specify the hash that you want to do. But it probably should be like base 58 crypto hash or something. Could be, but yeah, it doesn't matter.
Hey, I have a question actually about that big blob storage thing. So doing it in the way that this contract does it, you mentioned, it's the most efficient way to store like 300 kilobytes. How much are you actually gaining in terms of efficiency versus, let's say I just have a collection, it's like lookup map, this account ID owns this 300 kilobytes of storage. Like, are we losing stuff? Like, is it burning extra gas? Like, what's the
So the alternative, you probably, if you use JSON and like you use something like base 64 vec that you pass as an input, it's probably gonna fail at this deserialization. It's just not gonna be able to handle it. If you use Borscht and just pass a vec U8, then it's fairly efficient because it's just a memory copy. But because you're using it within the WASM, our gas meter doesn't think you're doing a memory copy. It will think you're doing a loop. And it will charge you for entire size of this base operation. So you just burned 300 base on gas. Now, that's only to get the input into the method. Next thing you want to do is to hash it. In order to hash it, you pass this vector into env_SHA-256, which will take this vector, move it into a register, then hash this register and read you. So you kind of wasted time on one copy already. And then you want to put it into the collection. And the collections right now actually do not support native vectors. So every collection is it will do Borscht on vector, which is an unnecessary operation. And then you will just run another serialization of the Borscht on top of the object. So you will burn a ton of gas on this, and like next time you need to read it, you will also burn a ton of gas on the read due to Borscht serialization of the pure vector, which should be just a copy. That's why like this is better option.
Okay, so just to summarize, let's say I had a method and it basically just took in a vec of U8, you know, so this U8, right? Like unsigned integer.
Yeah.
So that's okay because Borscht is going to be smart enough to just realize, oh, I should just copy that in.
No. You like when you serialize something like, you know, here, when you do something like pubfn store blob, and you say, oh, this is serializer Borscht, right? You say blob of vec U8. So this object will be serialized by first writing the size of the vector and then the vector itself. And the reason for this, because you can have a second argument. So for example, mat string. And because you need to know the length of the first argument, even so the mat also serialized with Borscht. Let's see if I can do the cargo expansion on this for you to see what the result is. But it essentially creates a structure for the arguments that is containing two values, blob and mat, and then run Borscht deserialize on the input. But because you need to know the size of the blob, the Borscht spec will write 4 bytes of the length of the first blob. So that's already not a pure copy. But within the vector, it will do a copy. So it will, okay, let's take 4 bytes of the length, read the length, and then do a memory copy of 300 kilobytes. And then,
right, but if you had, for example, like if you had a 300, what about if you have like a 300 kilobyte string or like some other thing? Like, does it get more? Does the inner operation, does the inner serialization or the inner steps that Borscht takes with the vec, do those get less efficient?
Yeah. Only U8 is a pure copy. The rest is like it will call Borscht on every element.
Okay, so if you're putting in like a giant string, right? Like
no, string is also memory copy, but it will do call from UTF-8 on a string, so it will also make it a bit more expensive.
Got it. Okay, just trying to understand like where the kind of like the extra sort of accounting bits come
in. While it tries to expand my method, we can take a look how the act proposal issues self-upgrade, for example. Where's okay, here's this upgrade self. So let's look what's doing upgrade self. We read the current account ID, method name migrate, attached gas. We calculate how much gas we're gonna burn on this operation, and the remaining will attach. And then we do low level stuff again, which is I need to modify that to work properly. But we read the blob into register 0. We create a promise using low-level promise API by passing the account ID. We attach action deploy by giving a promise index and a code from the pointer of register 0. And then we say go call on the same promise ID. Go call method name without arguments. Well, maybe this is can be an issue, but I don't know how we handle it without. Oh yeah, we don't. Well, I actually don't know how JSON handles it, because you pass in not. Maybe you need to pass something like this. Then we don't attach anything, and the remaining is attaching gas, and we don't actually return this promise, but we return the value. And okay, let's go back here, and upgrade remote is doing, well, it's not super efficient because it does a storage read into a vec and does a function call. So instead we should just use upgrade self, but pass the account ID there and the method name. So that's not efficient enough. Okay. Then but it returns promise value, and this one returns this promise. I guess it doesn't matter. For consistency, we can use this, so it's going to be more efficient. And I don't need to modify the blob stuff. So we're out of time. So let's actually complete this quickly.
I was just talking to a partner recently who was really curious about all the different ways to upgrade. That would be a really fun video if we had kind of small examples of each different way you may want to upgrade and how you can do it. Just thought of that.
Okay. So I need to replace a few things. So first of all, I need to do account ID. I guess it's the same. Like I can just use a string to pass there. I need to cast it to bytes. Then I need to again construct the storage key, but I can do this from here. And this should be a crypto hash instead. Now I can do this, and finally method name I have, so it's all good. And I need import. And that's it. So we basically unified upgradability. What else you can do is you can do borrow. Actually, let's see. We need to do return promise or promise return. In case we are not gonna override it, but who knows, maybe it's gonna work. That's it. Well, not that I'm missing still the fact that proposals has to be base 58 crypto hash instead, because we do return base 58 from storing blob. Private, who wrote this? Anyway, any questions on the upgradability, I guess?
I just want to second Mike's comment. I think we should do next week just a video on upgradable patterns.
Sure, yeah, it makes sense. I'm still compiling a bunch of stuff, like all the compilators that we have in near core has to be compiled because of dev dependency. And that just takes forever. Like have so many duplicates on the input. So like 2 crane lists, Wasmer runtime core, another like Gimli objects from 2 versions, bunch of first None of this I need for what I'm doing, but it's because the target is invalid. Well, anyway, let me stop sharing. And yeah, so that was not a full Sputnik review, but we covered a very interesting pattern, which is, I think, upgradability pattern that will be more important in the future. Especially we need an ability for most of the contract to either receive a blob of data and then upgrade with this blob of data. Well, actually, the way I did remote upgrade is incorrect, so it's not going to work because the predecessor has to be the current for this action to be accepted. So instead of deploy code, you actually have to pass the code. So, but anyway, it's a different point. So yeah,
Cool. Thanks. Yeah, that was very interesting. I'd never seen that approach before, for sure.
All right. Thanks, everyone. Bye.
Cool.
Thanks. See you guys.